Okay, so my screen is are visible, right?
Yeah, now it's visible.
Okay, so quiz one, right? So quiz one. So there will be like around. Let me see the question pattern. So there will be 12 questions. So and total 50 marks question will be there, and there will be MCQ, MSQ, and the NAT. So there will be uh, 50 marks and MCQ, MSQ, and NAT will be there, and it will be like similar to practice assignment questions and graded assignment questions, and I will recommend solve all the like PYQ. So that will be like beneficial for quiz one. And for the last some session, like I took that quiz one revision session, so maybe you can watch, that will be good. So maybe I'll just paste the link.
Okay, sir.
Okay, so you can watch last two term revision
Last.
session. So just watch that two revision session, that will be sufficient for quiz one. So and I'll strongly recommend like solve all the PA and GA and PYQ. So that will like understand what type of question will ask in that quiz one. So that will be sufficient for this. Okay, Rahul, you can start.
Okay, sir. I will. I'll just. Okay, at a later stage, I'll just take a screenshot of your notebook that you just shared, sharing the number of questions and all that, and paste the YouTube links on the what is it called, GSpace and WhatsApp as well. But for now, I guess let's begin with the doubts and a few other questions we'll discuss. First of all, like as you know, Muskan, there's only two PYQs that you have. One is the January 24 term, and the other one is September 23 term. So two
Yes.
papers to that. Maybe do the end term paper as well. You'll see a lot of questions from 1 to 4. So that will give you more questions to practice on. PAGS will be more than enough to do it. I mean, I have done it. That has been quite satisfactory. So when it comes to your question, Muskan, you had that thing, right, of that big circuit.
So, Rahul, you have some disturbance when you are speaking.
Is it?
Extra, yeah. There's some sound of wind extra. So,
Okay, okay. Is it better now?
yeah, it is better. Yeah.
Okay. Maybe it's because of the fan. So, for the question you had shared, let me just
Yeah.
share, open the image and let's discuss that. I'll share my screen. Mm, Can you see this?
Hmm. Yes, I
Okay.
see. Okay, so that's the case of 100 in the P.
No, just forget it. Um, yeah, you can see the screen, right?
Yes, I can see this.
Perfect. So over here, what you have to do is just, instead of going, okay, let's not do it that way. Let's go through the question itself over here. This is the one, right?
Yes, that's the question.
Okay. So what's the question first of all? So for the logic circuit given above, what is the combination of inputs for which F will
Output
be,
will be high, correct. High
output
means
will
that
be,
the value of F would be 1, correct?
F would be 1. Exactly, exactly. So In short, before going through the options, what I would recommend to you is just go through the options and do the calculation and see which one is giving you high. But before going ahead with that, just think, this is a, what gate is this? This is a NAND gate, right?
Correct.
So what outputs of NAND gives you 1? Pretty much all of it, except when inputs are both 1, right?
Correct.
NAND is 0 only when both inputs are 1. Otherwise,
One. Otherwise, it
even if
is one.
one of it is 0, it is high, correct?
Yes, correct.
So let's go ahead and try that logic out. If one of the inputs to this gate is 0, that means it will be high.
Hmm.
Okay. All right. So now let's just go through the options. First option, A0, B0, C0. If we go through that, if A is 0, just look at this gate. What gate is this?
XOR.
This is a XOR. What are the inputs to this?
So the input of this would be 0
0. One
and
is A, one is
0
B.
and 0. So it would give us 0 only. XOR.
XOR would give us 0. Why? Because the inputs are 0, 0. XOR
So
gives 1 when it is 0, 1 or 1, 0, right?
1 0, correct.
So in this case, we already have 1, 0. So we don't need to check the other one. It will always give 1.
Hmm.
Makes sense? One of them
1
are 0 means
0.
output is 1.
Yes, correct.
So option 1 is good.
Correct. Yeah.
Option 2, 0, 1 and 1. So 0 is coming here.
Hmm.
1 is coming here.
Yeah.
So 0 and 1 will give you 1,
Yeah.
right? So this one is giving you 1. But we need to check if this one is giving you 0 or not. Correct?
Correct. Hmm.
So let's do this gate. What's the first thing? It's this one. This
And
one taking what? B bar.
B bar, A bar, A bar. Basically, A ka NAND gate, so that means it would be A bar only.
A bar. Matlab this is coming as 1. Okay.
Correct.
But think of it like this. This is a AND gate, correct?
Yeah,
AND gate gives 1 only when all three are 1. It will give 0 otherwise, correct?
correct.
So look at B. B is 1, right?
Base one, so it would be 0. Yeah,
It would be 0. No point checking anything else. It will
correct.
be 0.
Correct.
So यहाँ पे you're already getting 0, correct?
Yeah.
And over here, what is the input here? It's 0, right? Because C is 1 and this is a not.
Hmm.
So this is 0, this is 0. This is a,
Or 0, not, then it will give us 1, and above is also 1, so that's why it will give us 0.
it would give you 0. So option 2 is not correct.
Yeah.
Okay. Now coming to option 4, because this was also not a problem. Problem was this. We'll go to that later. And then,
Okay.
so A1, B1, C1. Okay. So A1 coming here to this XOR.
1 and 1,
B1 coming here. 1, 1 will give you what? 0.
0,
So one of the inputs is 0. No point checking anything else. Output is
1.
1.
Correct.
Now your problem is this, right?
1 and 0.
1, 0, 0. So this one is taking 1.
1. So it
This
would
one is
give us
taking
1.
0.
Give us
1, 0 would give you what?
1.
1.
Yeah.
Okay.
Now,
Now checking this one.
yeah.
C is also 0, right?
Yes.
So
It would give us 1.
wait, look at this AND gate first. This will give you 1. We'll
Yeah.
go to that later. Look at this AND gate first. AND gate is taking what?
0. So A bar is 0. So
A
that
bar is 0. So no point. ये 0 हो गया. ठीक है?
and C also, C is 1.
C is 1. Yes. So 0, 1. 0, 1 ka NOR is what? It's
1.
0. 0, 1 ka NOR. NOR is not of OR.
0 1 ka NOR, yes, it is 1.
It is 1. Huh?
No, it is
Yeah,
0.
0, 1 ka NOR is 0.
Sorry, it is 0. So 1 and 0. So 1 and 0. It would also be 1 high.
It would also be high. Therefore, this option is correct.
Yeah.
Is it clear now?
Yeah, that's what I was saying. In the answer, it is only A and D.
Oh, okay. That was the thing. That's an issue. That was an issue before as
Yeah.
well.
Okay,
So when this was
Muskan
this one
will
also,
update the answer.
Yeah, thank
before
you, sir.
also the same thing. So this option C is also going to be correct. No.
Yeah, it is correct according to me. Yes.
Hmm. Okay, so let's try to. I saw a few interesting questions.
Yeah, let's out there.
Wait, let me show you that. Let's go to the PYQ. 1 minute.
Okay.
Where is that? Can you see this tab, PYQ tab?
Yeah.
Okay, let's try to do something that is a bit different from what it looks in the questions.
Okay.
There are few very basic questions. Let's not dwell on that. We'll do this, but we'll do this at a later stage. Do let's do this timing diagram. Okay.
Okay. Answer.
So, huh?
Yeah, yeah. Continue,
Yeah.
continue.
Okay. So, how do you interpret a timing diagram? See, at the end of the day, all you need to see is that should be inbuilt into your instinct and stuff. Is that take a note of all the expressions which give you output one, right? That's
Yes.
the approach. So, what are the outputs that are ones which are high, correct?
Correct.
So, for this high case, what are the values of A, B, C? It's A
So
bar, B bar,
zero, B0, C1.
C1, which means A bar, B bar, C.
Yes, correct.
And what is the
Plus
expression here?
plus A, B bar, C.
A, B bar, C. Now, A bar, B bar, C plus A, B bar, C.
Yes.
Take B bar, C common. What it becomes? A plus A bar.
One.
A plus A bar is 1. So, what is the minimized expression? B bar,
B
C.
bar. So B bar NOR gate,
How many gate would you need?
we only need two gates.
Two gates. One to do the NOT, one to do the AND.
Yes, correct.
Now, if you have any issues understanding NOT, how many gates, this, that, the other, the easiest way of doing it is just decrypting, debugging the Boolean expression and making it a NOR expression. Okay.
Yes.
NOR is what? You need a plus sign between the expressions and you need a NOT on top.
Negation over the
Hmm,
expression. Correct.
at the top. So your expression is B bar C,
Hmm.
right? Now, if we put double NOT above it, that means same.
Yeah. So
It means
and
the same.
we will try to open one negation. So
One of
that's
the negation, you will do not on the two and put plus in between. So
yes.
what will it become? It will
B
be
plus C bar.
B plus C bar whole
Uh,
not,
uh, whole negation.
whole negation, right?
Yep.
So B plus C bar whole negation is basically B not C bar.
Yeah. NOR
So
gate.
one NOR gate there,
Yeah.
and if you do C NOR C bar or C NAND C bar, sorry, C NOR C or C NAND C, it
Hmm.
negates it, right?
Yeah.
So for getting C bar, you need one NOR, and for getting the whole expression, you need two NORs. Therefore, the answer is two.
Two. Correct. Yeah.
This one is clear.
That's
Okay, I'll show you one more uh, interesting question. This one is a bit lengthy, I would say. Have you tried solving this?
consider the circuit given that the input are supplied uniformly random. What is the probability of F being 1? Okay, so what I will do here, I will simply simplify the expression which it is making here.
Hmm.
And then I will simplify the expression and then I could get the probability easily.
Yes, but the way of doing it is just find what is the F's expression, which you just said.
Yeah.
Okay, take a note of it on one side, and then you have how many inputs? W, X, Y, Z. Four inputs.
So, yeah.
So how many possible Boolean combinations you can make? 16.
Yes.
Just make all those 16 combinations and find the value of F for all of it.
Okay.
Okay? And then you know how many will give you one, and you have 16 in total. So those number of
Oh,
things.
I got it. So according to we can do it through truth table probability, right?
Yes, yes, it's truth
Yeah.
table approach only.
Yeah. Okay. Got it.
So this will give you eight number of high outputs. So that is why it's 16.
It was
Sorry, that's why it's 0.5.
yeah, we had something like this in assignment also. In
Integrated assignment,
also,
yeah.
yeah, yeah. So I think it came out as B or C in the end, only one. Yeah.
Exactly. It was very minimized in the end.
Yes.
So it became very short. In one of the cases, probably it was a singular expression as well. In another question, if I'm not wrong. Okay, this is another interesting question. This, I'm not sure if it's in graded assignment, but this is another one. See, some operation is happening between x and y here, and whatever is happening there, the output of which is going through another operation with z, and then we have a final output. Correct?
Correct.
So what is the expression they have given?
So
It's
like what we can do here, I think we can take a common of Z from here. Like
exactly, because z is isolated here as well. So try
correct.
to isolate z here.
Then we can apply the 11D, I think. X naught Y plus X, the 11D formula,
Hmm.
in which we will get X plus Y. So
A plus a bar b equal to a plus b.
yeah. So we would get X plus Y plus Z. So this is only two OR gate.
No, no, no. How is it two OR gates? If you take z common, what do you have? X bar y plus x, right?
Sorry, or and. Sorry. Yeah, my
Or and.
yes.
GT1 is or, because what is it becoming? X plus y ho raha hai
I thought I forgot that I took the Z as common. I thought it was in addition.
na? No, no, no. Z is multiplied. Multiplication means what? And
Yeah,
gate.
yeah,
So GT2 will be and, GT1 will be or.
yeah. Or correct, correct. Yeah.
Correct? This is also quite straightforward. You just have to
Write it
it
once.
accordingly.
Yeah.
These things, 3 by 8 decoder circuit and all these. Please memorize the circuit or just go through that enough, because if you do not do that, you will forget how many gates you need. How does it 3 by 8 decoder circuit looks like?
Okay. So given this,
It's like this.
oh,
This is a 3 by 8 decoder circuit.
I didn't know that. Okay.
That was probably, I'm not sure if it was there in the lectures, but you have to know this.
Okay.
So
So
there is a delay over there, right?
correct.
Let's just
Can
go
you
back.
show the question once? Yeah.
Yeah.
Given that note and two input and an OR gate have delays 1 second.
1
What?
nanosecond delay of each of these gates, correct?
Hmm.
This much you have understood?
Yeah. So
So
what is the maximum delay?
what is the maximum delay of the circuit possible, right? Let's go back to the circuit.
Yeah.
This is the circuit. So say there is a delay, I mean some gates not functioning or some other thing is happening.
That is like only see whenever we have a NOT gate in
Hmm.
whatever expression, that will have 1 second delay, 1 ns delay, right?
That will have 1 nanosecond delay,
Yeah.
and
So
finding the and is also going to have 1 nanosecond delay. That is the
correct.
worst case. So worst case is what? One here, one here, two.
Yes.
For the others, if it's directly going to
It's
the
one.
AND gate, it
It's
is
only
only
one.
one. So that's not the worst case,
Yeah.
right? That's not maximum. So maximum is when it is hitting all the gates. So 1 makes it 2. So 2 nanosecond is the maximum delay.
But it should not be like what will be the maximum delay. But the delay is only 1 second, right?
Why
Like
1 second?
because when can you show the diagram once again?
Yeah.
So here, when we are not using not, we are completing it in 1 nanosecond. When we are going through 2 nanosecond, they both are taking 1 nanosecond time. So the delay is only 1 nanosecond, right?
How is it 1 nanosecond? You
So
need all the 8 outputs, right?
correct. So like all the expressions which
Hmm.
don't have not gate, they
Hmm.
will be resolved in 1 nanosecond, correct?
Yeah, there will be only one expression which doesn't need a NOT. That is D7. Baki everyone needs NOT, no?
Yeah, okay. Everyone needs that. So D7 will be only waiting for 1 nanosecond. So
1 nanosecond.
they
Yeah.
only 1 nanosecond, right? Every for the 1 nanosecond other, it is already evaluating the expression. No.
No, no. How is it evaluating the expression?
Okay, I have one more question. Like in the graded, we did it like that. That is why I am 1 second.
No, no. See, whatever is happening, say all these. See, you can't just make do with one or two or five of these outputs. You need all of them, right?
Correct.
At the same
So,
time.
but the 1 nanosecond is utilized by everyone. So there's no delay. You can say. Or
Oh, in that regard, you can say that there is no delay, but because of this not gate, I mean, say if because of these AND gates, that 1 nanosecond delay, whatever is happening,
Hmm.
that will be consistent. For this one, there is no delay, you can say to some extent, but there is a delay because of this AND gate at least. So 1 nanosecond for this, two for all this. You can't just say that there was the maximum, na, worst case, maximum delay of the decoder circuit.
Can you
So
show me the
even
delay question in graded assignment? I have done a doubt in that question.
okay, 1 minute. Which week was it?
I have
Oh,
to see. I am also searching for that.
let me see. Three. I
I
think
think
this one. This one.
because
This
of
one.
it, but I am not. Yeah, that's
This
the
one,
question.
this
Okay. So in this question, what we did, like we had 5, 12, 10.
one.
5 is for our NOT gate,
Hmm.
12 for and OR. So if I try to go from this, I will have 5. Then AND gate will take us around 17.
Wait. I'll. Okay. At this point, can you see the cursor?
Yes,
So at this point, my current delay is what? 5.
5, correct.
A is coming after 5. At
Yeah,
this point, what is my total delay? It
5
is 17.
plus or that is 15, correct. Yeah.
5 plus 12, 17. Oh, sorry. Odd is 10. Yes, 15.
Yes. Yeah.
So F is getting the first output after 15, right?
Hmm.
How about this?
Here we have 5 plus
You have
12. So
5,
that will be 15. 17, sorry. 17
17
plus 5,
plus
22.
that is 22. So this guy is coming here at 15 seconds, nanosecond, whatever.
Yeah. So we
This
have,
is coming after 22. So
so we have,
this input here basically has to wait for 7 nanoseconds before it can evaluate the output,
proceed further. Correct. Yeah.
right? So when it comes to stability or glitch, it's about you're not getting all the inputs or there's some issues with that. So
Okay.
the issue will persist for 7 nanoseconds because the first input has come, but the second has not.
Okay.
So it's
Okay. Now
basically the
I get.
difference between the two.
Yeah, yeah. Now I got it. I thought it was also about the maximum duration delay. Yeah. Okay, I got the question.
Yeah, it's the time that the first guy has to wait before the seven. It's about like having two
Difference.
keys to unlock a door and one guy is waiting there for the other.
Yeah.
So it's something like that. So that is why it was 7 nanoseconds.
Okay. Okay, I got
Back to this.
it. So there are also other decoder system like 3 by 8 or some else.
3 by
So you just showed me 3 by 8
3
diagram.
by 8.
So
I think
there
3 by 8 was mentioned in the lecture somewhere. I think
is
not.
there any other decoder circuit
Wait, wait, wait.
which can come?
I'm not sure. Shubhendu sir would probably say like if
I
there's
think
we need
like
to go through.
decoder. Yeah, my audible, right?
Yes.
Yeah, you're audible, sir.
So
Please.
2 to 4 decoder, I think it's explained in the lecture. So it's similar to like 3 to 8 decoders. So it's in the lecture. So you just have to watch.
Okay.
Yes.
Okay, so thank
So 2 to 4 and 3 to 8 is what they need to practice, right? Or
Yeah.
understand the circuit.
Yeah. Yeah. 2 to
Okay.
4 is sufficient. You can, according to that, you can make 3 to 8.
Hmm. Hmm. Okay. Just 1 minute. Hmm.
you. Yeah.
All right. Let's try to solve some other question as well. Let's see. If you do PYQs, GAPAs, it's more than enough to solve all the questions in exam. Okay.
Okay.
One trick here. One trick here. You understood the difference between the SOP, POS, and
Yes.
Sigma and Pi, right?
Yes, I
So
understand.
whatever you have in Pi,
Hmm.
everything other than that is Sigma, I mean, that
Correct.
is how I had
Yeah. That is sigma, and other is min and max terms.
min and max term.
This is min terms, and other than this is max term. Pi is our min term.
No, pi is your max term.
No, it is min term.
Okay, yeah. Okay. So if pi is giving you 1 to 3, I mean, if they want to find you pi of 1 to 3, first thing you need to notice is how many expressions do you have here? You have 3, right?
Three, right?
So how many possible numbers you'll have? 8.
8.
So you have 3 here. You need another set of 5 for the sigma. So what
Yes.
would that set of 5 of sigma have?
0, 4, 5, 6, 7 from the truth table.
From the truth table, yes. 0, 4, 5, 6, 7 from the truth table. So you have to minimize that one, and you can
And
find
then we can get the answer.
you can get the answer. And just to tell you, have you learned K maps?
I did, but I don't remember it much.
Okay, the shortcut and the easiest way of doing it would be just make the K map and do it. You don't have to go through the tedious Boolean expression minimization.
Can you show it once? Like,
Okay,
just.
I'll show you a K map. We'll do this question on the K map itself. 1 minute.
Okay.
Okay, let me open this. Okay, let's come here. Let's try to do this on a Excel sheet. All right, what was the question? Uh,
It was min term of 1 to 3.
Pi of 1 to 3. Okay, fine. So it means sigma of.
I am not able to see the sheet.
Oh, sorry. Can you see here?
Yeah.
Sigma of 0, 4, 5, 6, 7. Right?
Correct. Yeah.
Okay. So you have a 3 expression thing, right? So let's just start here. Let's put 1 on the x-axis and 2 on the y-axis. Yeah.
Okay.
So let's say a here and a bar here, and on the y-axis what we'll have you gone through the K-map lectures and all that?
No, I don't. I am not going to yet. But I know, like, we will write it as truth table, right? So we will
Uh,
write it.
not necessarily a truth table, but it's kind of like a table which will have all the numbers and everything. So
Yeah.
over here, if you it's a 3 expression thing, right? So we have a bar here. What we'll have here is
BC, B
no,
dash
not
C, B
not
C.
not basic. No.
Okay.
0, 1, 3, 2,
Hmm.
4,
Yeah.
5, 7,
6.
6. So no, sorry, it won't. It won't be that. 1 minute. Just give me a minute.
First one will be A bar, then A. Rahul, first is A bar, then A.
I think he is not here.
Okay.
Sorry, yeah. So the first one, my bad, it's going to be a bar. Second
Yeah.
one is a.
Yeah, it is according to truth table, I think. I remember because it has one variable this side, so it would be 0, 1. And in this, we have two numbers, so it will start with 0, 0, 0, 1, 1, 0, 1, 1.
0, 0, 0, 1. No, 0, 0, 0, 1, 1, 1, 1, 0.
So,
That's the thing.
yeah, because it is 3, 2. Yeah, correct.
Because the reason is while going from one cell to the adjacent cell, only one bit can be
One
changed.
bit can be changed. Yes.
Okay, so that is why we don't put 2 here, because had it been 2, it would have been 0, 1 to 1, 0. 2 bits would have changed.
Yeah. Correct.
So
Now
let's
I remember. Now I also remember this. Yes.
good, good. So it's BC bar.
Oh, it should be B bar C. B bar C.
Oh, sorry. Yeah, B bar C, BC, and it will be BC bar. Correct.
Yes.
So that is how it is written. Okay. So what we need to map? What we need to map here? 0, 4, 5, 6, 7.
So
0,
that would
4,
take.
5, 6, 7.
We
So
will just multiply left and top. Right.
no,
Okay.
just we'll mark those. Generally, what we do, we mark that by x, or no, not x. We mark that by 1.
One.
Okay. Now, what we need to do, we need to take common as much as possible. But
Hmm.
how much we'll take? We'll take in 2 to the powers. So we can take 2 things in common, 4 things in common, 8 things in common. Okay.
Yeah.
And how can we do that? We can either take it in a straight line. So all these 4 can
Or
be
in
taken in
square.
common.
Or we can take a square.
We can take a square like this, but since there is no 1 here, we cannot. Or we can take a tuple. We can take 2.
Yeah.
And there are other rules with respect to, like, if you have 1 here, see it was nothing here, nothing here, and nothing here. You could have taken this and this in common. How? It's that this is kind of like circular. So half from this end, half from this end can be taken.
Hmm.
Okay, it's
Yeah.
foldable basically.
Corners. Corners. Yeah.
Corners, yes. So for this, you will get the minimized expression. As much minimized you will get if you take many common at a time. So what should be our target? We should take 8 at a time. Can we take 8 at a time? We cannot, because there are only 5. What can we take? 4 at a time. Are those in a straight line? Yes, they are in a straight line. Correct.
And we can take A from common from them.
Huh. Now the next question was, what is the common here? Common is A, right?
Yeah.
So we write A here. So these 4 have been covered. So
Hmm.
this guy is sitting here alone. If we only write this, it's going to be A bar, B bar, C bar.
C bar.
But that's tedious. We
Hmm.
can reduce it even further. How? We can take these 2 common. You
These
can repeat. You can repeat. And that is why you can take these 2 common. So what will happen? B bar, C bar. So what is your final expression? A plus B bar, C bar.
Yeah. Yeah. Okay. I remember. Yes. Correct.
Okay.
Hmm. Yeah.
So now when you come back to this question, you know you have an issue here. You have these 3 options and it's not matching. It's what was there?
Yeah. It was not matching.
You
Yeah.
had x plus y bar z bar, but you need 3 expressions.
Hmm.
Wait a minute. Why am I not able to shift? Yeah. Okay, let's do this first. You need 3 expressions. So all of these has 3 expressions. What you can do, you can try to minimize this one as well. So
Hmm.
how will you do that?
Yeah. We can take X common in second and third term.
Sorry. You can take x common in second and third term, but
And that would give us our A.
yes, so, you can take the first term, duplicate it, and take common with second and third as well. That can also help,
Yeah. Oh, yeah. That also
right?
works.
So what would you do is, if we take these 2 common, y bar is common, so it's like what, x plus x bar z bar,
11D. 11D formula.
11D formula. So that will
X
come with what,
X
a
plus
plus
Z bar. X plus Z bar.
x plus z bar.
Yeah.
So y bar into x plus z bar. Now do the same with xy and x bar y bar z. Can anything happen?
No. We cannot take anything common in first and third term.
You cannot take anything common.
Yeah.
But can you do anything else?
Hmm.
No, you cannot. You cannot. So you can only go ahead and do it in this way. So you will have what, x plus sorry, y bar common, y bar common a plus a bar b, x plus z bar.
Are you writing something?
No, no, I'm not writing. Let me write it here. Y bar common x plus z. Uh, what was it?
Single quote. Single quote.
A plus a bar b, x plus z bar, right? X plus
Yeah.
plus
X Y.
x y.
And Y should have bar in first term. Y bar.
Oh yes, y should have a bar in first term. Okay. So what you have here, xy bar plus xy plus y bar z bar. Correct?
Hmm.
Now, what can you do? You can easily write, change the first expression to x,
Yeah.
because
And
taking
we got our answer. And
y
we got
plus y bar will become 1,
yeah, we got our answer.
y plus z bar, y bar z bar. And you got the answer.
Okay.
Doing it using the truth table gave you this expression, but after doing this, you would have to, just expand it in a different way. It has to come
Yeah.
with y bar z bar. It's like, what is it called?
I
Reverse engineering.
in this scenario, I think both will take equal time if we do it originally.
It's your choice. Whichever approach you may think that
Yeah.
you would prefer, just go ahead and do that.
Hmm. Okay.
Let's try to solve. What is it? This is 25th Feb 24. So this is the January paper. Okay.
Consider given.
Yeah. Let's try to do this.
Okay. F is always at 1.
Hmm.
And it is a min term.
Hmm. So if you want to do it in a max term representation, what will you do? You'll do 3, 5, 6, 7, right?
Yes.
So once you take 3, 5, 6, 7, just find the minimized expression and build the truth table
Hmm.
and see what are coming as high for how many inputs. Well, let's do this one as well.
Okay.
Okay, 0, 1, 2, 4, right? So let's just come back to this. 0, 1, 2, 4. Zero, 1, 2, 4. So where will 0 be? Here, 1, 2, and 4. Correct?
We are representing min term here now.
You're representing max term here.
So it would
Okay,
be
wait. It was pi of 0, 1, 2, 4, right? Sorry.
yeah, so 3, 5, 6, 7.
It would be 3, 5, 6.
6, 7.
So just remove this. 0, 1, 2,
2,
3,
3,
4, 5, 6, 7.
3. Yeah.
Okay. Okay. So how will we do it?
So we have 3 quadrants now. One is in BC, vertical, and 2 is from the left side and right side too.
We have to take 3 tuples. There's no way we can take 4 or just 2 and
Yeah.
1. Right?
Yeah. 2, 2, 3 tuples. 2, 3. Yeah.
3 tuples. 3 2 tuples.
Yeah.
Okay, anyway, let's for this one, what will be the expression? It's what?
BC
Easy.
plus A
For this one, what is the expression?
plus A.
It's what? AC, right?
Yeah, sorry, yeah, C also. Yes, correct, correct.
And for these two, AB.
It could be AB.
AB. So now just it's simple. I think we'll do the truth table. A B C 0 0.
0 0 0 0.
Hey, sorry, 0 0 0 0 0 0 1 0
0 1 0
0
0 1 1
1 1
1
0
0 0
0 0
1 0 1.
1 0 1 1 1 0 and 1 1 1. Okay.
Yeah.
Now let's do AB, BC, AC, and this is the final one, right? So
Yeah.
what is AB? AB is 0 0 0 0 0 0 1 1. Correct?
Mm. Yeah.
What is BC? 0 0 0 1
1 0 0 0 1.
1. What is AC? 0 0 0 0 0
1
1
0 1.
1. Okay. Now F is what? This
0
or this or this, right? So 0 0 0
1
1
0
0
1
1 1 1.
1. Yeah.
Okay. So what was the question? We have the truth table ready. Now let's get back to the question. Question is, for which of the following conditions of XYZ the output F is always at logic 1? 2 or more logic 1, 2 or more logic 0, something or the other. Let's observe the truth table.
Okay, one thing I have, we got the same values as 1. Okay, but we need input. Yeah.
0 1 2 3. For the previous question is what you're saying. Oh,
I was saying that we
yes.
got
It's the
we the
it's the same
KMAP,
data. It's the,
KMAP was not needed here.
you already had it. That's true.
Yeah.
Was there a way of identifying it? 0
Yeah,
1.
because we had max terms, so we could like directly we could skip this A B B C. We could have write F directly.
Yes. Yes. We could have written that directly.
Mm.
Okay, yes. Why did we do that in the first place? But then we didn't know if we could have taken anything common, isn't it? That's also a thing. Had it become something different, then we would have been in trouble. Okay, let's try to highlight this. Okay, so these four rows are our rows of focus.
Yeah,
Let's get rid of these columns because we don't need these.
we don't need this. Yes.
So these three. So for these three columns, so what is your
So
observation?
everything has 2 or 3 1.
Everything has two or three ones. So number of ones is greater than equal to 2.
2. Yeah.
Okay. So let's see if that is an option over there. Two or more inputs are at logic 1.
Any odd number is not valid. Any not input 1 or 0 not valid. Okay.
Not correct. Okay. So this one is easy. Makes sense.
Yes.
Okay. Let's try to do what is the minimum number of circuits. Okay. Let's try to do this. Say we have only two input XOR gates. What's the minimum number of XOR gates needed to represent the circuit diagram? Okay, for this one, what are the inputs that are coming here? It's 0, 3, 5, and 7.
0 3 5 6.
Sorry, 0, 3, 5, and 6. And they are going to what? They are going to
NOR.
NOR. So, how will you approach this one?
I think for this we can make a truth table of 0 3 5 6
5,
with
6. Yes.
the three inputs, and then we can apply the NOR on the three values which we are getting.
Hmm. But you basically need Y.
But how
You
do
have
we
to
know
make
that?
the expression for Y.
How do we know? How do we know that what gate is applied in A, B, and C? I want to ask that.
What gate is applied in AB? Here,
ABC, yes.
nothing is applied. There are just three basic inputs. That's it.
Okay. Okay, then okay.
Nothing is applied here. You have 8 possible combinations with 3 inputs.
Yeah, yeah. So and that with
Basically, T0 is A bar, B bar, C bar.
yeah.
So you have to do a NOR on these 4 expressions
Yeah.
and you'll get a Y.
So that would so we have to calculate how many XOR. I think we can simplify the terms and we would get XOR in some
You
way.
will simplify the terms and you'll get a XOR based expression.
Yeah, yeah.
So that will give you 2 XOR gates in that case.
Okay. I will try this.
Yes, try this. That would be good. Okay, how will you identify this? The
Okay.
way I had done it
So
was very
here
straightforward.
we have for A, B. We are getting 1. So that would be A naught, B naught.
What? Wait, what? AB what?
First will be 0, 0, right? It would be 0. First, first would be 0. So 1 into 0, it would be 0 for first one. So it would not be considered. Second, third, we will only consider the last value
Why?
because everything else is becoming 0.
How?
So first, in first one, our selectors are 0, right? So that is why it is making it 0.
How are the selectors 0? What are the select lines?
So A and B are selectors in the first one. So A
A
and B,
and B are selectors. That's a different thing. This is a multiplexer. A and B are selectors. If A and B are both 0, then this input will be chosen to push here. Okay. This is a different combination. This is a different combination.
yeah,
These are
but
inputs. These
okay.
are selectors.
So we
They don't have any relationship with the inputs. They only choose which line to use.
yes,
So basically, what is A and B doing here? A and B is only pushing 0 and 3.
yes,
So
correct.
is it to some extent acting like one of the gates? Does it look like a truth table of one of the gates?
In one,
What gate
so
is this?
it is not of zone.
Not of XOR, which is X NOR,
Yeah.
right? And the X NOR is coming here. And the same thing is happening here, right?
Yes.
And it is doing with C,
See.
correct? So
Okay.
basically, what can we say? It is A X NOR, B X NOR, C.
Yes. All are X naught.
So it's A
That's
X
it.
NOR, B X
X
NOR.
naught sign. Okay. But
Shubhendu sir, you there?
so it's not here.
Oh, hello. Yeah, yeah, Rahul.
This is an acceptable approach to this question, right?
I think this is like both are correct answer. A or B or C and A X nor B X nor C both are the correct answer. If we solve, we'll get the both are the correct answer.
Okay.
Yeah.
All right. So let's do another question. Otherwise, we'll move to another paper as well. Okay, this is a very straightforward thing. So you have 0, 1, 2. You have 2 is to 1, 2 by 1 marks, right? So how many marks you basically need to get these 3 outputs?
Yeah. 0, 0, 0, 0, 0, 1, 0, 1, 0.
Yes, but you have 3 inputs, right? So what could be the minimum number of marks you need? For marks, you get different combinations, correct?
Yeah.
So if it's 2 is to 1 marks, it means what? There is one output and there is 2 inputs,
Hmm.
right? So just like it was there here. So one output, 2 input, and there will be one select line.
Yes. One selector.
So
Yeah.
you have 3 inputs here. So will you be able to do it using 1 marks?
So
You won't, right? Because 1 marks only supports 2 inputs.
to support two inputs, so it would not be possible for us to incorporate three input.
Hmm. So just like here, it would be 2:1 marks. There'll be only two input lines here, one select line here, and the output will go. So, but this will only give you two input ka thing, right? For the third input, you have to take the second marks, correct?
Yes.
So you'll take the third input. What was it? Z. So you'll take Z input here, XY input here. One marks will give you the evaluation of X and Y, and the second marks will give you the operations done on Z. So you'll be able to make this expression using two marks.
Hmm.
Yeah. Acha, one tricky question from here. Uh, had it been 0, 1, and 5, how many marks would you have needed?
0, 1, and 5. Then also again 2 multiplexer because we have 3 inputs only, right?
Then also you'll have to two
Right?
multiplexers. Yes,
Yeah.
because you will be able to do it. Okay, no, that's a bad question. I'll give you something else. Wait. 0, 1, and 11. How many marks do you need?
0, 1, and 11. Then it comes under 4 bit.
Yeah.
So it would be, so 4 bit can only be 4 bit can only be represented by 3 multiplexers.
You would need the third one.
Yeah.
Yes.
Yes.
All right. Let's do this. This would now seem to be very straightforward. So let's try to do this.
XOR,
What?
XOR,
Just forget everything. Just what is this? What is the output of this?
0.
I didn't, not zero. X can be 0, 1 both. How can you say it will be
Okay,
zero?
sorry. Yeah. it
It is
will
X,
always it will always be X naught.
it is X. It's a X
X
NOR
bar.
both, right?
Yeah.
So what do you get if you do X NOR of something
Oh,
itself?
it would give us exact input same. thing.
What would it be?
It would be X only.
Is it 0 X NOR 0 is what?
1 second. Okay. X. If the expressions are same, it would give us 0. Then not.
Let me let me do it there. Should I do it there on the
Yeah,
X?
I think it would be X only.
No, it's X, right?
Yeah. Yeah.
Okay, X XOR X NOR X.
X.
Okay.
Okay.
So now let's write it this way. Better
Okay.
to understand. So X or X. What is zeros or 0?
0.
It's 0. What is ones or 1?
1.
Ones or 1 is 1.
Sorry. 0. Yeah.
Ones or 1 is 0.
Yeah, sorry.
X dot X will be 1.
1.
This will also be 1.
1. Oh, so we will take as 1. Yeah. Okay.
We'll always get 1.
It will always be 1. I was thinking it as in, yeah. Okay. I got it now.
Will always be 1. Now we will XNOR it with, what are we XNORing it with? We are XNORing it with X again.
Hmm.
Okay?
So 1 and X. 1 if 1 bit is
Let's wait.
1 0 1 1.
We are XNORing it with X, right? So how many combinations will it be? It will only be 2, right?
2. Yes.
Because XNOR X is giving you consistently 1. So no point making 4. So XNOR X, no, sorry, wait. It's going to be complicated now.
I cannot see the screen of Sheets.
Oh, sorry.
Yeah.
XNOR X.
Okay. Yeah.
So this was the first XNOR X output,
Hmm.
and we are XNORing it with X again, right? We are XNORing it with X again to
Yeah.
get this, right?
Yes. Makes sense.
Makes sense. So what is this?
So it would be 1 and then 0. So 0.
So 0 1 would give you
0.
XOR will give you 1, so XNOR will give you 0.
And
1
bottom one will be 1.
1. ठीक है,
And then we have, I think,
two combinations.
yeah,
Now we will XNOR it with, no, now it's not XNOR. Wait,
it is another gate. It is another gate.
it is a XOR gate now. It's a
XOR gate. Okay, XOR
we have
gate.
to XOR it with X. Correct.
Yes.
X can be 0, X can be 1.
Visible.
Sorry, need to switch.
Yeah. So it would be X nor X nor XOR X
X XNOR X
X
X
nor X
X is
XOR. Yeah.
okay. Now let me push it here and let's write X
We'll
here.
write here. 0 and 1. Oh, then we have four
Wait,
possibilities now.
combinations. Wait.
4 possibilities.
But
Also,
then that does not.
change the heading of this second tab.
This will go here,
Yeah.
and this will come here. But
How do we-
we are doing some mistake. 1 minute. We are doing some mistake here. The answer here is 1. Okay, let's go to the gate again. First gate is X XNOR X, right?
Yes. It should be uh
X.
Zohar.
What should be XOR?
Need the results are in 1 and 0. Like we are not
Hmm. It is 0. The result is 0. We are doing some mistake. Wait. So X XNOR.
write it there. Let's do it one by one. Okay. Write it
Write it.
from start.
Write it where?
Write in sheet again with X. Let's do it again.
Let's do it again. Yes. So let's trace this back. And remove all this, the outputs. Okay. So X can be either 0 or it can be 1.
Yeah.
So X XOR X. 0 or 0 is what? It's 0.
Mhm.
0s or 1s or 1 is 0. So X not X. X not X is always 1, right?
Yes.
So it is always 1.
Yeah.
X can
0.
be 0, X can be 1. Okay, what's the next step?
Again
Next
X.
is
Again X. No.
X nodding the same thing with X. Fine. So 0 1 will give you what?
So
Zero.
we'll do XOR first. Okay. Let's do the XOR first here. Then
Okay. Let's do XOR first. X XOR X.
X not. Yeah.
Okay. So 0 1 का XOR is what? It's 1.
Fine.
1 1 का XOR is 0.
0. Then it would be 0 and 1.
Then it would be 0 and 1.
So it is dependent on X only. Here we have got X only, right?
Right. So it's basically
X only.
X itself.
Yes. So that's where we were doing mistake. Yeah.
Yes. So it's X itself.
Yeah.
So if it's X itself,
So we'll do the same thing as the first step again.
0 0.
So it would give us 0 only.
And
Okay.
then 1.
Now see the first table we did.
Now if we look at this, it's
Yeah.
only a simple XOR there. So it will always give us 0. See, this was a mistake here.
Yeah. This
This
was
was a
our
mistake. It will always give you 0. If you XOR, so
Yes.
0 0 ka XOR is what?
0 only. Good question. You need to notice.
Unfortunately, it will not come in the exam. Okay, 0 0 ka XOR is 0. 1 1 ka XOR is 0.
Yeah. So it would give us 0 only.
It will give us 0. Anyway, moving on. A simple truth table approach helps in most of the questions.
Yes, true. That's true.
As long as you don't do any silly mistakes, it's good. I was honestly stuck on this one for a very long time at my time. This is
Oh,
my version.
okay.
Okay, this one. Please, I can give you 100% assurances this question is going to come. Not the same number. These base conversion and all that, this is going to come. So make sure you practice all of these. And the only way of doing questions like these with these 100 many options is trial and error. But you cannot just go on wasting time trying six combinations, right? So what should be your approach? What do you think should be your approach?
Sorry, what?
uh, this question is going to come for sure. So you have six options. No other way to try than trial and error. But is there a trick here? Can you see it? Have you observed it mostly?
Yeah, it can be easily solvable. We did these questions in assignment only.
But what is the approach so that you don't waste time doing solving the wrong options? What do you think?
Uh,
Tell me. I'll tell you in the end. First, you tell me what could it be.
I will do it with the simple approach we did in.
Simple approach of what? Okay, I'll tell you. See, look at the numbers, observe the numbers. Most of the time, you may not have something like this, but just in case, just an observation. The first number is 3451, right? Second number is 32121.
Hmm.
So second number is basically almost 10 times the first number, correct? It's a huge number. So that means what? That the base here is quite larger than B.
Yeah.
So you have to find a base of A. You have to
Where
find
the A is less than B. Yeah. A
where
is
A is greater than B.
okay.
A is greater, tabhi to this number is becoming so much larger than this 5-digit number. This is just a mere 4-digit number, right? And this is a 5-digit number. So you have to see that the base is so big that this number is still becoming equal to this. So that means the base of B is small, lot
Hmm.
smaller than A. And when it is becoming almost 10 times, it means it's almost double. So which options can you eliminate? You can eliminate this one. This is close, 8,
Only
7.
the only the first, third, and fourth letter.
First, third, and fourth. Yeah. Although fourth and second, first is also quite. This one looks very unique and odd. So my first instinct would be trying this one. So since you have a number this big, it's very highly likely that A is almost twice as big as B, because the number represented by A is almost 10 times that of B. So if
Hmm.
you do 16 base here, 16 into 1, 16 power 0 into 1, plus 16 power 1 into 5, 16 power 2 into 4, plus 16 power 3 into 3. And then do it this way.
Yeah. I can do it. Yeah.
This is not a
Hmm.
very difficult question, but you can save time thinking of it that way. Okay. A system uses 6-bit binary code to represent characters. How many distinct characters can the system represent? Um, 6-bit binary. So 1, 2, 3, 4, 5, 6.
It is 2 to the power 6, right?
64. Yes, it is actually 2 to the power 6 things. Like that means what? 6-bit binary code means there are 6 spaces, right? So you can have two combinations in every space. I mean, talking from a mathematical approach, like probabilistic approach that we did in foundation. So like 2 into 2 into 2 into 2 into 2. So 2 to the power 6. So that many characters you can represent. There was one tricky question there that
Okay,
was.
I will do the previous year. I have to leave.
Mhm.
Sorry.
This is one. This is only quiz one. Just look at the end term as well.
Yeah, yeah,
If you have the links, if you don't have it, just drop a text on WhatsApp. I'll send the link to that.
yeah, yeah, yeah. Sure, sure. Thank you, thank you.
Yeah. Okay. So anything else that you would want to discuss? Anything from graded practice assignments?
No, no, no. I just had one doubt that the answer was not correct for one question.
Okay. Okay. That's good. Uh, Let me just see if there's anything that's
Um,
important. These are simple truth table things that will be solvable.
yeah, yeah, I'm done with PhD. Okay, all activities. Yeah.
Okay, let me just look at one thing here.
Hello, Rahul.
Okay, we did this. Certainly, okay. Yeah, Shwin sir, tell me.
I think Muskan can solve other question in like own way.
What?
Like Muskan can solve other question like
Yeah, yeah.
Yeah, yeah. I mean, solve it and just drop me a text on GSpace or
ah
something.
yes, yes.
Yeah,
I'll
yeah,
check
I
it
will.
out.
I will.
I
I
think
will.
it's enough.
It's enough, huh? For
It's enough.
Yeah,
huh?
yeah.
Yeah, it's
Okay, okay.
okay.
And Shubhendu sir, can you share the screenshot or
Yeah, yeah. I'll share the inscription and all the things.
just share it and they'll be able to see how many questions and all that. Okay.
Ah yes, yes.
Okay.
Okay then. Thanks, Muskan. Thanks, Rahul. Bye bye.
Okay. Thank you, sir.